Hello students, welcome to Physics by GSB. Today we discuss about electric field due to a uniformly charged insulating sphere. So first of all, we consider a sphere, insulating sphere. First of all, we consider a insulating sphere having center O and the radius of a sphere is capital R. Capital R is the radius of insulating sphere. Consider that the charge on a insulating sphere is Q. Q is the charge present on the insulating sphere, and this is a insulating sphere having volume charge density rho. Rho is the volume charge density of a given sphere. As we know, electric field due to a insulating sphere, charged insulating sphere is radially outward. Means the value of electric field at every point having equal distance from the center of the charged insulating sphere is equal. Now, first of all, we consider a point P outside. Case first is electric field at point outside the sphere. This point will be P outside the sphere, and the distance from center of the given insulating sphere and the point P is small r. This is the distance from center of the given insulating sphere and point P. Now we draw a Gaussian surface around the insulating sphere having radius small r. So according to Gauss theorem, electric flux at point P is total charge enclosed inside the Gaussian surface by epsilon naught. As we know, total charge enclosed by the Gaussian surface is, this is the Gaussian surface. Gaussian surface. Total charge enclosed is Q by epsilon naught. Okay. Now, electric field, and we know the value of electric flux. Electric flux at point P is electric field into area. What is the area of this given Gaussian surface? Is electric field is given as E into area is 4 pi r square. Now we know the value from equation number first is Q by epsilon naught is equal to E into 4 pi r square, and the value of electric field is Q by 4 pi epsilon naught is equal to r square. This is the magnitude of electric field, but in the form of vector, in vector form it is written as E vector is equal to Q by 4 pi epsilon naught r square r cap, because electric field is radially outward. Okay, now we discuss about electric field at point on the surface of the given insulating sphere. Okay, Now, case number second, electric field at a point on the surface of given sphere on the surface. Now, in this case, a point P lies on the Gaussian surface. This is point P. Now, Gaussian surface also lies on the boundary of the given surface. This is Gaussian surface, just above the surface of the given sphere. This is the r, small r, the distance between center of a given sphere and a point P. Now, again, according to Gauss theorem, electric flux is given as charge enclosed is Q, as usual, Q by epsilon naught. This is equation number first. Now, according to definition of electric flux, phi is equal to electric field into area. In this case, E is equal to E into 4 pi capital R square, because small r and capital R both are equal. So electric field, if we put the value of phi E is Q by epsilon naught, then E is equal to Q by 4 pi epsilon naught R sphere. This is the electric field on the Gaussian surface, and this is the maximum value. Okay, now we discuss about electric field at a point inside the insulating, charged insulating sphere. Point inside the surface of a given sphere, inside the surface of sphere. Now let us consider that the point P lies inside the sphere. This is point P, and the distance between center of a sphere and test at point P is small r. Now again we draw a Gaussian surface. In this case, Gaussian surface is inside the insulating sphere. This is our Gaussian surface. So according to Gauss theorem, phi E is equal to Q is the total charge on the given insulating sphere. But in this case, we does not consider a complete sphere. We consider a sphere having radius small r. So in this case, we consider charge enclosed by small sphere is Q dash, according to Gauss theorem, by epsilon naught. But what is the relation between Q dash and Q? As we know from the definition of volume charge density is rho is equal to charge by volume. Now volume is 4 by 3 pi r cube. Okay, so rho is equal to Q by 4 pi r cube. Now we consider again we use the definition of, this is equation number first. Okay, so in this case, what is the value of Q dash? Q dash is equal to from this definition rho into V, and then Q dash is equal to, what is the value of rho? The value of rho is Q by 4 by 3 pi r cube, and volume in this case small sphere is 4 by 3 pi r cube. Okay, then we cancel out these factors, pi with pi, and Q dash is equal to Q into R cube by R, capital R cube. So we use these factors. Now, according to definition of electric flux is E electric field into given area. What is the area of given sphere? And this area is E into 4 pi r square. Gaussian surface की बात है. Now, what is the value of phi E? Phi E value is Q dash by epsilon naught. And now electric field is Q dash by 4 pi epsilon naught r square. Now put the value of Q dash from this relation. E is equal to Q R cube by capital R cube into 1 by 4 pi epsilon naught r square. Value is E is equal to, here is cancelled out with Q, so Q by 4 pi epsilon naught r cube. Okay, this is the electric field inside the sphere, insulating sphere. Now we combine the all three results. What is the relation between electric field and distance from the center of the given insulating sphere? The relation is that will show the electric field and that actually shows the distance from the center of the insulating sphere, charged insulating sphere. First of all, we know that the first result that as we, from this inside the sphere, as we increase the value of R, the electric field really increases, means directly proportional to R. So this value shows the electric field and relation between E and R. Linear relationship means E is proportional to R. But at that point where small r is equal to capital R, radius of the given charge insulating sphere, small r is equal to capital R. Means the distance between center of charge insulating sphere and test charge point P is small r is equal to capital R. After that, a point outside the given surface, given insulating sphere outside point, then electric field is inversely proportional to R. Okay, in this case electric field decreases with this relation. This will shows E is inversely proportional to R square. This is the factor in which electric field depends. Okay,